Hi, I'm Callie Stoskup. I'm a site reliability engineer. And in this challenge, which is challenge 3 of the Deploy in Public workshop, by the way, if you haven't done 1 and 2 yet, go ahead and back up and do those. You can find 1 here and 2 here. Hopefully I did that right. Anywho, in challenge 3, we're going to explore multi-availability zone deployments. The idea is, what if AWS's availability zone 1 is down? Well, you want to back up. You want to make sure that your application is still live for users to use, even if an availability zone is down. That's why you have 2, and then you use an application load balancer to balance the load between the 2, only sending traffic to the ones that are healthy. So, if that sounds fun to you, keep going and do this challenge. If that sounds super confusing, it might be worth doing the challenge anyway, because you learn the most when you're slightly out of your comfort zone. Enjoy the challenge.
We're to get started on our next challenge. We're making the architecture a little bit more production ready. And it's also time to clean up our Terraform. So you can see we just have one big main Terraform file. And while that works, it's not optimal. We want to be able to have our Terraform written in a way that's readable and reusable. Okay, so we're going to start by making a new Terraform module. You can think of a module as abstracting some of the code out, and then you can use variables as inputs to that module to make provision different types of resources or different configurations of those resources. So what we are going to do is we are going to edit the Terraform that we had from last week in order to make it into this challenge. And we are also going to modularize our VPC. All right. Each week we'll kind of, from here on out, modularize a different component of our Terraform resources. It would take too long to do all of it at once. Okay. But we will do the VPC this week and the new architecture. All right, so let's go ahead and set that up or start setting it up. So what we need to do to make a module is we need to create a folder and we're going to name it VPC. All right, within each module, then we're going to have a few different files. We're going to have a file called providers.tf, and that's where our providers are going to go, which makes sense. All right, so something like our AWS provider will go in this providers.tf file. So I'm going to go ahead and copy provider AWS and throw it into the providers.tf file. All right. The next thing that we are going to have in this folder is a variables.tf file. Now, we hard coded everything here before. All right. But just like when you are using other languages, you use variables so that way you have some flexibility in your code. All right, what if I want a different CIDR block here? Well, instead of just hard coding it here, I could make a variable for the CIDR block and then fill it in at a different spot. That doesn't seem super helpful in this example because, like, well, I could just fill it in differently here. But you'll notice when you use the same thing over and over, that's where this comes up. All right, and we'll get there. So there we'll be there. So let's do a quick example. Here we have the provider AWS and the region is hard coded as US East 1. Now I'm in US East 1, so that's what I would use. But what if I wanted to push my repo to GitHub and then allow you guys to pull down the repo and provision some resources? If I had my region hard coded here, in US East 1, you'd have to search through and you might accidentally put your resources in US East 1 if, say, you're in US West 2 or wherever. All right. So this is how we are going to do our variables. You will have your variable file, and then you define a variable by saying variable, and then you will name it. So we're going to call this region. And then we are going to have type equals string because the region is going to be a string. And then we're going to have description, which is going to be the region where we are creating the VPC. Okay. You can also use the property default to add in a default value. Okay, so I'll go ahead and add it in US East 1 there. So now instead of US East 1 being hard coded here, we can write var.region, and it will pull this region in and use the default variable for our region. All right, so those are two of our files. There are two more files we need to add. So the next one is called outputs.tf, and we're not going to do anything in outputs.tf right now, but that is going to be the outputs of when after we provision our resources. This is like, well, what information about our VPC do we want? So the VPC ID, right? So let's go and look here. So if I do VPC, okay, so you can see here, well, that's in our subnet, which would be in the same VPC module, but let's go find where we're using vpc.main.id. Bum, ba-dum, bum, bum. All right, so here in our security group, we're adding our security group within this VPC, right? So if I'm having a VPC module, in order to access it from the main here, we need to have that VPC ID output from the module. Okay, if that's confusing, that's okay. It'll make more sense as we keep going. And I'm not going to worry about it in the outputs right now because we're just going to focus on making the module. The most important part then is going to be our main.tf file. Now, this is where we're going to define all of the resources that we are provisioning, and we are going to get started. All right, so let's go to our main here. And we're going to kind of copy and paste and edit as we go. All right, so here we have our resource, our AWS VPC main with our CIDR block and our name. And then we have our public subnet and our private subnet. So I'm going to start with those. And I'm going to copy them. And I'm going to paste them into our main VPC file. All right. So good. Now, in our main VPC here, this is looking good. Otherwise, the only thing I'm going to do is I am going to take this CIDR block and I'm going to turn it into a variable. So I'm going to say var CIDR block. Then I'm going to go over to my variables and I'm going to define it. The type is going to be string. The description is going to be value of CIDR block. That's fine. And the default is going to be, and then let me paste this in here. All right. Perfect. All right, so the next thing that we need then is, so now we have our AWS main, all right? So before we were just doing one public subnet and one private subnet, all right? And you can see that we were putting it in the availability zone, US East 1A, US East 1A, okay? So we only had one availability zone. But why is that a problem to only have one availability zone? Well, what happens if that zone goes down? Well, if you are in production, you always want to have at least two availability zones because if one goes down, you want your users to still be able to use your application. So if you have your application running in multiple availability zones, that is ensuring as much as you can that your application's not going to completely crash and you're not going to have downtime for your consumers. Okay, so how do we do that? And we could copy this block and paste it down here and then say, oh, all right, now we want this in US East 1A and US East 1B. The issue with that, though, is, again, we are adding variables here, and we're saying that the user can define the region. The user of this Terraform will be able to define their region. So if they can define their region, then the availability zones have to be within that region. So what we're going to do is we are going to use the data type. Sorry. So let's do Terraform data availability. and let's give it a try. So here you can see that we are going to use the data block to get the available AWS availability zones, okay? And we're basically filtering by the state that's available. So I'm going to put this above my resource block, all right? And then I'm going to press save. All right, what I'm actually going to do now is I'm curious to see what that's going to spit out. So I'm going to minimize all of these things because I don't want to create them right now. Then I'm going to comment them out. All right. And I'm going to also add an output block here so that way I can see. So I'm going to make an output block. I'm going to call it availability zones. And then I can put data value is equal to data dot AWS availability zones dot available. I'm going to just leave it like that and see what happens. Then I'm going to CD into my VPC module, and I'm going to say Terraform init because I haven't initialized the module yet. Perfect. And then I'm going to say Terraform apply. All right. So here are the zones. Oh, here are the names here of all of the availability zones. So I think that's also why they put names here. Dun, 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 dun. All right, let's say no, we don't apply that, but let's try again so that way we can see just the names. And here are the list of availability zones. Cool. All right, let's go back to our main now. So why did we do that? Well, the reason that we did that is so that way we can create public and private subnets in the availability zones. Now, we could copy and paste here like this, but that's violating the dry motto of do not repeat yourself. So let's go ahead and go up here and we're going to look up the idea of count. All right. So count is a meta argument defined by Terraform language. It can be used in modules and every resource type. It accepts a whole number and creates that many instances of the resource or module. So here, what I can do is I can use the property count or the meta argument count, and I can create that many resources. So if you looked at our architecture for this week, you're going to see that we want to have 2 public subnets in each of our availability, in 2 different availability zones. So I'm going to say count is 2, okay? And then we're going to keep going from there. All right, so the availability zone, not going to have that. We're going to not have it like that. Instead, we're going to say data.aws dot availabilities or data dot aws underscore availability underscore zones dot available. So that's coming up here. Dot names, all right, in order to get the names, right, of our availability zones. And then that's a list. So then we're going to say at the count dot index. Okay, so that's going to give us this availability zone for the first subnet and then this availability zone for our second subnet. Perfect. All right. And our tags are almost correct, but we have coding with Kali, public subnet. But what we want in actuality is going to be to add count index on the end. So that way we know the differentiation between the first one and the second one. Then I'm going to add +1 because index starts at 0 and I want to be able to see public subnet 1, public subnet 2. Okay? All right. Our next issue is going to be these CIDR blocks. Okay? So before, what we did is we took that main CIDR block, right? This one here, and then we split it into 2 halves, right? So we had 125 and 125, I think that's what it was, or something like that, IP addresses in each of our subnets. But now we have it in 4. So what we want to do is we want to do a subnet or CIDR subnet calculator. I think this is the one I used beforehand. All right. Okay, so let's go get then my CIDR block. All right. Then we're going to say update. All right, and so then now what we want to do, so this is going to be our subnet address if we have one subnet. So we want to divide. So now we have 2 subnets, which makes sense because that's what we had before. Then we're going to divide each of those into 2. So now we have 4 subnets. Each of them have 62 hosts. Okay? So now that we have that, we can go ahead and use that in our VPC. Okay? So, dun, 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 dun. All right, so we're going to say for here, we're going to say count dot index is equal to 0, right? So count index is either going to be equal to 0 or it's going to be equal to 1. All right. And so we're going to say if it's equal to 0, then we want the subnet address to be this. Okay. Or we want it to be equal to, yep, that's correct. All right. So that looks good. So now we want to do a similar thing here. So we want to say that our private is going to be count 2. All right. And then our CIDR block, our availability zones, let's do that one next. I'm going to just copy and paste this line here. So again, this is going and getting the first 2 availability zones from this data here, and the data block reaches out to our provider, which is AWS, and gets the availability zones. All right. And then instead of coding with Kali private subnet, we want to add on then the index +1. All right. So one more thing to change for this subnet. Thank you, Copilot. This looks great. All right, so now we have this. So now we have our VPC, we have our public subnets, and we have our private subnets. Let's go ahead and Terraform apply and see how we did. While we do that, I'm going to go ahead and sign in to AWS. And you can see we're adding 5 things, which makes sense. VPC main, and then 1 public subnet, 2 public subnet, 1 private subnet, 2 private subnets. So yes, we want to create that. And then I'm going to go look at the VPC in my AWS console. All right. I'm going to pull this down and open her up. All right, so you can see that now we have our coding with Kali VPC. If I click on it, you can see the little map, which this is super helpful. You can see that we have public subnet 1, private subnet 1, which makes sense. Those are both in US East 1. Then we have private subnet 2, public subnet 2. Those are both in US East 1B. You can see that everything routes to the default route table, and we have no network connections, and we don't have any other route tables. So now what we need to do is we need to go ahead and start adding our other resources. Before we do that, though, I see some places where we can refactor and we can make things a little bit better and more reusable. So the first thing that I see is that we're hard coding CWC into everything. And so basically, coding with Kali is like our quote unquote app name. So what I want to do is I want to replace everywhere that we have coding with Kali, I want to replace with the variable.app name. Now that doesn't exist yet, which is why we have a little red squiggly. But if we go over here, we can make it exist by saying variable app name, type string, description value of app name, and then here we can say coding with Kali. So now that should plug in to these spaces. All right, so let's go ahead and Terraform destroy. Perfect. And then let's Terraform apply to make sure that that worked as intended. All right, let's open this up bigger. Let's go back to VPCs. All right, let's refresh. So we still have a coding with Kali VPC, and then we still have everything named the way it should because our variable is working. All right, the next thing that I see is the CIDR blocks. They're hard coded, right? Up here, we made the CIDR block friend the entire VPC a variable, so it doesn't really make sense to hard code these here because if we hard code these here, then and somebody puts in a different variable for the CIDR block, then things aren't going to work. So what we want to do instead is we want to add a variable here with variable, and then we're going to say public subnet CIDRs. And then type, which is going to be a list of strings, description, value of public subnet CIDRs. And that looks good. Let me just make sure that was what we had for public. Looks like it has the opposite for public. It shouldn't matter. All right, and then let's do private subnet CIDRs, and that looks good. So 10.0.0.0.26. All right, 10.0.0.64.26. 10.0.0.128.26, 10.0.0.192.26. Okay, so that looks good. Now let's go in here and we will change it. All right, so if count of the index is equal to 0, then we're to say var dot public I'm actually curious if we could just do var dot public subnet CIDRs at count index, right? So the first count will be 0, so it'll send in 0 from this list, and then the second time it'll send in the first one. Perfect, and then we can add that here too. Perfect. All right, so let's go ahead and Terraform destroy. And Terraform apply. All right, let's make this bigger and let's double check that we did this correctly. All right, so go in and take a look. Subnet 1, subnet 1 private, subnet 1 public, public, private. Do we have any that are the same? Nope. All right, perfect. That looks good. Awesome. So we have our VPC all set up, but we have no route table and no internet gateway. So that's where we are going to move on to next. All right, so I'm going to go back to my main file. All right, you can see I no longer need these 3 resources because I already have them. But I do want an internet gateway, and I do want a public route table, and I do want the public subnet association. So I'm going to go ahead and copy these and paste them over here in my main VPC. Now we're going to need to edit to make sure everything makes sense still. So the VPC ID for the internet gateway still makes sense. Instead of coding with Kali here, we are going to use our var.app name. All right, perfect. And then we are going to, where are we going next? Route table, public route table, that's fine. This VPC is correct. And then our route will go to our internet gateway and back. And the only thing we need to change here is adding that var app name. Our route table association here. So here we need to change it where we need to add count to, because this route table association is associating a route table with one public subnet, but we have two public subnets now, so we need to have two associations, okay? And so here, instead, we're going to say AWS subnet, right? That's the resource type. So go do this, dot public subnet. That's our name of our subnet that we want to associate with the route table. Then we're going to, because we have two of those, and that is a list, then we are going to say at the count.index, which would be 0 and then 1. And then we will have .id to get the ID of that public subnet. All right, and then our route table, we only have one route table, so that is perfect. But interestingly enough, we only have one route table, but I'm pretty sure we need two route tables. But let's go ahead and see what happens and let the errors guide our path. All right. Association. Yes. All right, let's give this a try and see if this works. Perfect. And let's refresh. So now we have two route tables, our default here, and then our public route table. So what's cool about this little graph here is that you can kind of click around. So you can see that the private route or the private subnet can only connects to the default, which then doesn't go anywhere, right? It just goes to the default route table. And the other private subnet also connects to the default route table. Now our public subnet, you see, connects to the public route table and then to the internet gateway. And same with our public subnet in the other availability zone, connects to the public route table and the internet gateway. So this public route table has two subnet associations, these two, and two routes, including local. So you can click on this little arrow to go take a look, and you can see that, yep, we have a route to the internet gateway, and then we have also a route where we can locally talk to the other applications within the VPC. All right, so I actually don't think we need two route tables for our public, so I'm going to say that's good, and we'll, I guess, figure it out if there's a problem later on. Let's flag that, okay? All right, so then now what's next is going to be our, let's just Google it. Do you need multiple route tables for multiple availability zones? Dun, dun, dun. Okay, so this person is asking that they can use a single routing table or multiple. What's best practice? Okay, so this is saying that if they're not uniquely different, then it might be simpler to have a single route table for public subnets. As an internet gateway is highly available and the VPC can only have one, it just adds complexity to add a route table per subnet if they're all the same. Okay, so now let's read on private subnets. For those private subnets that do require internet, you will need to use a NAT gateway, which is what we're going to use, generally the best practice is to have each availability zone have its own NAT gateway. This prevents devices in other availability zones being unable to connect to the internet. Yeah, so that makes sense, multiple NAT gateways. In this case, you would consider a route table per availability zone, then bind the subnets to the correct route table as appropriate. Okay, so we could have two route tables. We could just have one for the public, but it looks like because we'll have two NAT gateways, then we would have two private route tables. Okay? Sorry, taking a drink of my drink. Okay, so now let's go ahead and we can get rid of these resources from our main file because we have them in our module now. So we need our elastic IP address in order to make a NAT gateway, and then we have our NAT gateway. Then we also have our private route table and our private subnet association to that route table. So I'm going to copy all of this and I'm going to paste it in. All right. So our elastic IP address, all right, we want to have two of these because we're going to have two NAT gateways. And why do we have two again? Well, we have two because if one availability zone goes down, right, we still need the other instance in the other private subnet to be able to communicate with the internet. So the NAT gateway allows private instances and private subnets to communicate with the internet. So we need to make sure we have two NAT gateways and each NAT gateway has an elastic IP. Okay? So we will go ahead and create count 2 in order to have that. All right. And it depends on the internet gateway because the NAT gateway uses the internet gateway. The way it goes is that the private instance uses the route table to get to the NAT gateway, which is in the public subnet. And then the NAT gateway communicates to the internet gateway, which then communicates to the internet. All right. So here then we also need to have count 2. All right. So when we do this, we will have our elastic IP address .NAT at the index that we're at for the count. So that would be 0 and then 1 and then the ID. All right. And then for our subnet, we'll have it work the same way. Public subnet at count.id. All right. And here, instead of hard coding with Kali, we will do var.appname in that gateway. Perfect. All right. The next thing that we're going to do then is our private route table, which will have count 2. VPC ID is fine. And the gateway ID here is going to be instead using the count because we have two NAT gateways. We also are going to have two route tables, and each of them will use their own NAT gateway. We will then change this here to var.appname, and that's going to be our private route table. The final thing that we need to do is the association. So because we have two tables and two subnets, we want two associations. And each association, unlike what we had to do before, where both subnets are being associated with the same route table when we're doing the public route table, here instead we are going to do this. So that way we are associating the private subnet 0, right, first with our, nope, and that went to public. All right. So here we're going to have the first private subnet associated with our first private route table, and then our second private subnet associated with our second private route table. And each of those will then route to their own NAT gateway, all right, which then will route to the internet gateway. So here now I should be able to just say Terraform apply, and then it will tell me the changes that are going to be made. So let me pull this up. All right. So yeah, it's saying that line 67 is deprecated. So I'm actually going to just get rid of it because that is the default anyway. And that should get rid of that warning. All right, so it's going to do 2 private subnet associations with route tables, 2 private route tables, 2 NAT gateways, 2 elastic IP addresses for the NAT gateways. And we are going to say yes. And then we can make this window bigger in a second in order to take a look at what we've done. Gotta just wait for it to finish. The NAT gateway takes a few minutes, so if it goes a little bit longer, then I'll go ahead and pause. Yeah, I'm gonna pause. I'll go ahead and press play when it's finished creating. All right, so it's been a few minutes, but we went ahead and finished, and all 8 resources are created. So let's go back and take a look. I'm going to refresh this page and take a look and see how everything provisioned. So we have our VPC with 4 subnets in it, 2 public and separate availability zones, 2 private and separate availability zones. We have 1 public route table that routes us from our public subnets to the internet gateway. Then we have 2 private route tables, 1 private route table per private subnet that route to the NAT gateway. They each have their own NAT gateway. All right, so that one has a NAT gateway and that one has its own NAT gateway. But now I'm seeing that what I don't love is that I want to have a 1 and a 2 added to both of those. So I am going to go back and change that. I'm going to add a count in here. So that way I can see what's going on. And then same here. So that way I should be able to know which one routes to which. And I'm going to Terraform apply to update my changes. And it looks like we're just going to update in place, which is nice. So I'm going to click yes. And we modified. Let's pull this back open and refresh the page. All right, perfect. So now our NAT gateway 1 connects the private subnet 1 with the private route table 1 with the NAT gateway 1. Our NAT gateway 2 is connected to the private subnet 2 and the private route table 2. This is exactly what we want. All right, so now we have our VPC set up. Let's make sure that we don't have anything else that we want to create variables for. Not really seeing anything. All right. But what I do want now, so I'm going to pull this down because now we actually want to use this module. What does that mean? So let's go back to I'm going to close out of providers and move outputs over here. I like the order main variable outputs. All right. We actually don't need the availability zones, but what do we need? So I'm going to delete those because we already added them. All right. And you can see that we have an issue here. Wait, we see the white. So that means that we don't have that VPC. Well, why don't we have that VPC ID? Well, because we're no longer creating that resource within this main TF. So we need to output our VPC ID here in order to use it in the main file. So VPC ID, and the value is going to be AWS VPC.main.id. And you can see it's all blue because we have access to that. All right. So now let's go back to main. And what we want to do now is we want to create module. And then we're going to name it VPC. All right. And then in that, we're going to say that our source for that VPC is going to be in that folder VPC. And then we need to, and Copilot already knows, right? It needs these variables, okay? We set the defaults here, but honestly, that's not the best place to set them if multiple developers are going to be using this, or you'll use this module, right? You might use this VPC module and many different Terraform plans, right? So you don't want to have the default right there. You're going to pass them in instead. All right. So let's look at the variables that we have. Variable region. So region is going to be equal to US East 1. Then we have CIDR block is going to be equal to, and I'm hard coding them now, but I'll show you in a second what we are actually going to do with this. And then public subnets, private subnets. Let's just make sure that's what we have. Yes. Okay. So that looks good. All right. So now, okay, before we were, so I'm going to actually Terraform destroy this because we are building right in the VPC folder and we don't need to be building right in the VPC folder. Do, 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 do. All right, so it's still going to be destroying. All right, so the next thing that I'm going to do is I'm going to go ahead and delete these default values. So do I need a delete the default? No, because if you pass in values, it will just overwrite it. However, I don't want any mistakes to get made. So here what I'm doing is I'm just declaring the variables. I'm saying that these are the variables that I need. And the reason for this is then in the main VPC file, if I leave one of these off, nope, in the main file here, main.tf for the whole thing, if I leave one of these off by accident, it's going to give me a red squiggly line saying that I need to have it. All right, I like that personally because it's going to remind me what I need. Close out of that and reopen it. Why is it mad at me now? Oh, because I don't have app name. And see, I had forgotten app name. All right. So now I have all of these. What I want to do then is move all of those into a variables.tf file in my main folder. So this is outside of the VPC. It's in the main program. All right. And what I can do is I can actually, I'm going to go ahead and add those defaults back in, paste them in here. Then I'm going to go delete them. And again, the reason I'm doing this is because I want to be mandated to add my variables when I use this module. So this is like the main variable page for the main program, right? Then in the VPC, this is just telling us which variables we need to make this run. All right, so now instead of writing US East 1 here, I can write var.region. And that will pull it from this file here. Then this will be var.CIDR block. This will be var.public subnet CIDRs. This will be var.private subnet CIDRs. And then this will be var.appname. And save. All right. So now what I'm going to do is I'm going to go through and edit this. So now we have our main VPC ID here, but we don't have a resource AWS VPC to use. Instead, we can now use module.vpc.vpc ID. All right, let's go look for other ones. So here we have AWS subnet. We don't have that anymore, so we need to change this to module.vpc.public subnet IDs at 0. And the reason why it's not popping up is because we didn't define that in our outputs. So now we can. So output public subnet IDs and value is going to be that maybe. So what this is saying is, I don't like reading it like that. I like reading it like this, which should be the same thing. But this is just saying that any It's going to be AWS subnet. The reason why this is white is because it's a list and we're selecting all of them that go in here. All right. But we're outputting the public subnets here. All right. And how can we tell that? Let's CD back into VPC. Nope. We're already in it. Clear. And let's do Terraform plan. Also, by the way, if you don't have your app names, your variable names, this is what happens. So no, no, no. All right. I already did that. So I'm going to go back to the main folder, which is just this main file here. And I'm just going to use it and hope it works, and we'll see in a minute. Okay, so var public subnet cider. Nope, where are we? This is main VPC. We don't need that. We don't need the state. This is just our main file. So module dot VPC. So now if we delete this should pop up. Yep. And then we're just going to use 0. So eventually what I'm trying to show you is I'm trying to show you how the module for the VPC works and can just get the our old plans up and running. In our old plans, we only had one public instance. So this is just going to set it up. Right. And so in this one, we would do module.vpc.vpcid. And then now we need a public or private subnet. So we need to add that. So output private subnet IDs and VPC private subnet IDs at 0. Let's keep going. Let's do module.vpc.vpcid. Module.vpc.public subnet ID at 0 for the Bastion host. All right, so that looks pretty good in terms of now we have a module using a module to create all of our VPC root sources. And you can see now we're at only 204 lines of code, and before we were a lot higher. So this just makes it a little bit readable. We could also make different modules out of the other things too. You could end the video here because at this point it doesn't really matter it doesn't really matter to create the old architecture in terms of the public instance, private instance, and Bastion host, because that's not ultimately what we're going to do. But I want to test if it works, so I'm going to keep going, and feel free to keep watching if you want to do. Right, module not installed. So we're going to Terraform init, and that's going to make sure that we can use this VPC module in the main file. Now we can apply. And yes. All right, so it's creating it pretty good. So I'm going to end the video here. Nope. Oh, because we already have our subnet in the other one. Duh. So let's do cd VPC. Can I do Terraform destroy? Coding with Callie. I've gotten myself into a little bit of a pickle here because I started editing things before. So private. And then public. US East 1. Oh, all right. Well, dang. Let's destroy everything that we have out here. I might have to go in and, so 13 to destroy. Is it good to destroy? All right, it's destroying the VPC and such. So hopefully that destroys what we wanted it to. So now let's try to Terraform apply and see what happens. So yeah, that is a big lesson, which I'm not sure I really fixed it here. But if you start always like destroy before you start moving files around because everything's getting saved in your state. So if you're renaming something, it's going to have a hard time going and looking up like what you're destroying and what you're applying, and it might leave something around that you don't want left around. All right. So I am going to, it looks like things are creating okay. So I'm going to go ahead and end this video. I'm going to just do an extra video in the next one to finish setting up the infrastructure for the last two challenges and actually see if it worked to test our VPC module. Watch it if you want. Go ahead and move on if you don't. All right, see you in the next one. All right, if you were watching before and you saw that I got this error about the subnet, I thought it was because of like not destroying my VPC and then applying, but really it was just because I had a typo. I had both my public subnet CIDRs variable and my private subnet CIDRs input using the private subnet CIDRs variable. I had to change this one to public and destroy everything and then apply everything, and then it worked. Okay. So now to clarify, this video is pretty much just an extra. I just want to test that I set up my VPC correctly by doing the same resources as last week and the week before, where we have the ability to SSH into our public and our bastion, and then use our bastion to SSH into our private. I'm just going to install NGINX on both of the public and the private and just verify that I can ping the public on the public IP address and the private locally. But that's pretty much it. I'm not going to do the reverse proxy, and I'm not going to change the HTML page just because I'm just trying to make sure that I set everything up right. All right. So, keeping that in mind, I'm going to pull this over and I'm going to pull this over, and then I'm going to go to connect SSH client. Let's go ahead and use that. Then I'm going to SSH into my public instance. All right, well, I was able to SSH into it. That's a good sign. So then I'll go ahead and say sudo yum install NGINX. I'm in a public instance on a public subnet, so I should be able to install it, which I do, yay. And then if I say sudo systemctl start NGINX, it should start our NGINX server. So then if I go to the public IP address and I put it in my browser and click enter, I should see welcome to NGINX. So our public subnet and route table and internet gateway, that means all of that is set up correctly because I can see my NGINX. Yes. All right, so then I should be able to exit out of my public instance. All right, so now what we want to do is we want to go to our, oops. Oh, these are, you can see I was playing around before with my multiple hosts and such. You can see that these are terminated. This is from when I was spinning up and didn't realize what was wrong with my subnet and my typo from here. That's why you can see a bunch of terminated instances, because I had to Terraform apply and destroy a bunch of times. All right, so now you can see that I have my Bastion host, private and public. So let's go into the Bastion host. Let's do connect. All right, we need to run this, although probably not because we already just ran it. And then let's go to SSH add key to SSA agent. Let's go, because I forget how to do it every time. So let's do this eval. All right, so SSH is running. Then let's do SSH-add. Coding with kali-key.pem, identity added, and then we should be able to do SSH-a into our Bastion host in order to do forwarding. All right, so we're in our Bastion host now, and we did the -A, which should let us forward and connect to our private. So I'm going to just copy this. So I should hopefully be able to say SSH and then into the private. All right, perfect. So this is making me feel good that our VPC is set up correctly. Now we need to make sure, though, that we can connect to the internet through our NAT gateway. So I'm going to say sudo yum install NGINX. This does not feel great so far. Oh, yep, that feels good. All right, so we're able to connect to the internet using our NAT gateway. So then we can say sudo systemctl start nginx. And then we should be able to say curl localhost. Woo, woo. All right. So what does that mean? Let's get out of our Bastion host now. That means that our VPC was set up correctly because we were able to use our VPC module for our architecture that we had set up last week. But we only, as you can see, if you go back to our instances, we go to our running, we only have 3 instances here, and we're using a Bastion host, which if you look at the architecture design, we don't have a Bastion host this time. So we're not doing things correctly for this week's challenge. In the next video, we'll start setting up the rest of the infrastructure to match this week's challenge. See you in the next video. All right. So now that we've verified that our VPC module works and it's good, we're moving on to the rest of our infrastructure, okay? Now, if you looked at the diagram, you've seen there's no Bastion host on there. Why not? Well, traditionally, we used a Bastion host, okay? But now there's a new way that you can get into your private EC2 instances and do things without having to use a Bastion host to do so. Why did I teach you how to use a Bastion host? Well, we'll use it in the future, but we're not going to use it this week. All right. Instead, we're going to use AWS Systems Manager Sessions Manager. Now, what can it do? You can manage your EC2 instances. And why is that good? Well, you can use an IAM policy in order to set it up so that way you, from your console or from the AWS CLI, can manage your EC2 instances and basically use Session Manager to get into your host and edit the files, just as we did with the Bastion host. But we don't have to worry about the different inbound ports or the security groups that we did before. All right. This will clean up our code quite a bit because we don't need the different keys to do this. We will need to set up an IAM policy. We're going to start in this video by doing that manually. And then in the future, we'll use Terraform to do it. All right, so let's scroll through and figure out what we can get rid of. All right. All right, let's see. So we don't need a private key. So we can go ahead and get rid of that. As that was our only thing using TLS, we don't need the TLS provider. Already doing pretty good. We don't need a key pair. So we can get rid of that. And we don't need a local file to put our key in. Awesome. So in that, we don't need local either. All right, what's next? All right, so public security group. Now, you'll also notice on our architecture diagram that we don't have any public EC2 instances. All right, so because we don't need any public EC2 instances, we also don't need a public security group. And we don't have public instances. And why is that? Because before we were using the public instance as a load balancer. But now that we have 2 availability zones, this allows us to use an actual load balancer called an application load balancer, which we'll set up later. But just know for now, we don't need the public EC2 instance. We will have private instances still, so we're still going to need a private security group. But you can see that our private security group was allowing SSH traffic from the bastion host, and we don't need that. All right. So we can go ahead and delete this ingress from port 22. All right. We'll edit this some more later, but I'm not going to worry about it for now. We do still want a private instance, but here we are going to want to add our count. All right. So we're to say count is equal to 2 because we want 2 private instances. So now what do we do here? Instead, we're going to have it at count index because we're going to have a private instance in each of our subnets. All right. Do we need a key pair? Nope. Because we are going to use session manager to SSM instead of SSH into our instance. All right. So yep, and then we'll still use that security group. All right, here, instead of coding with Kali, we can go ahead and use our variable, which is going to be var.appName. And then we'll add a dash onto it with our count index +1. So that way we know which instance is with which subnet. All right, we don't have a bastion host, so we don't need a bastion host security group. And we don't have a bastion host, so we don't need a bastion host instance. All right. Perfect. Now, why did we need our IP address? Well, we needed our IP address because we needed to be able to SSH from that IP address. So now that we don't need to SSH, we also don't need to go out and get our IP address. And because we don't need to get our IP address, we don't need the HTTP provider. So you can see this really cleaned up so far. Alrighty. Now, this isn't done in terms of our architecture, right? Because we, as I said, will need an IAM policy, an IAM role for that policy, but we'll set that up manually for now. So for now, we're going to go ahead and we're going to provision our 2 instances with our security group. I am going to change this to just be like that. All right. And oops, did not mean to do that. And I'm going to now do Terraform apply. So it's going to add 20 resources and I'm going to say yes. Also, by the way, I destroyed between the last video and this video, so that's why it says 0 to destroy. And it's going to go ahead and take a few minutes to create that. So I am going to pause here and I will keep recording when this is done provisioning. All right, my resources are ready. So I'm going to go ahead and refresh over here and I should see perfect 2 private resources. Let's go ahead and explore a little bit further to make sure that those are in a different subnet each. All right. So I'm going to go to networking and I'm in for this one. My private EC2 1 is in private subnet 1. Perfect. Let's go to my private EC2 2. Let's go to networking, and it's my private subnet 2. Awesome. All right. So now what do now if I want to connect, all right, in the past, what we've done is we've had to go ahead and connect to SSH into our bastion host, then SSH from our bastion host into our private EC2 instance. All right. We are going to connect a little differently instead. So instead of this SSH client here, we want to go to Session Manager. Now we see that our SSM agent is not online and we're unable to connect. All right, so that's pretty sad, but we can go ahead and set it up so we can. How do we do that? Well, I'm going to go ahead and open up this guide over here that's going to help us set up the IAM role that we need. All right, so if I scroll up, we're going to go ahead and create a new IAM role. All right, so what they do is they connect to it from, they start the process from the EC2 instance that they just created. So we can go ahead and do that too, but because I have two, I think that's going to be a lot. So what I'm going to do instead is I'm going to just go to the IAM page here, the dashboard, and then I'm going to click on role because we want to create a new role. And you can see that I don't have any role for session management. So I'm going to go ahead and I'm going to create a role, and then I'm going to follow the steps. Now, you already know how Terraform works a little bit, right? So keep in mind that everything that we're doing manually here, when we switch over to Terraform, we will use Terraform to do, okay? So we have AWS service. All right. And then we will select a use case, and you can see that the use case they're selecting is EC2. All right. And then we have all of these options, and we are going to select EC2 role for AWS Systems Manager. All right. Systems Manager is like the umbrella, the bucket, and then within the bucket is Session Manager, which is what we're going to use. So Session Manager, you can see, is within AWS Systems Manager. Okay. So then we're going to click Next. Now you can see that we have this policy here. So we can take a look at it. These are all of the things that we are able to do, right? So SSM, all right, it's going to allow us to do all of these things using this role. So we'll go ahead and click Next, and then we'll enter a name. All right. Going to give it a unique name. We'll say something like Coding with Callie SSM. All right. And then we will create the role. All right, so now our role is created, and we can go ahead and go back to our EC2 instances. All right, because now we need to edit our EC2 instances to use that role. So we'll go to instance settings. No. Networking, no. Security, yep. So security, modify IAM role. Then we need to choose the role, which is going to be Coding with Kelly SSM, and then update the role. Let's go back to our running states, and we'll go to the next one. Actions, security, modify IAM role, and then Coding with Kelly SSM, update role. Then let's go to running, and what we're going to do now is both those have been modified, and we're going to go to instance state, and we're going to reboot it. The reason for this is because you need to reboot it to have the IAM role apply properly, so that way we can then use Sessions Manager. Took me a while to discover this. I went ahead and bookmarked the Stack Overflow article that showed me this, that I need to do this just in case you don't watch this video and you run into the same thing. All right. So now what we can do is we can go to Session Manager, which is going to be within Systems Manager. All right, and you can see that I had these sessions from yesterday when I was playing around with it. And I'm going to click Start Session. All right, and it's going to say what instances do we want to target, and I can select whichever instance I want. So let's say I want to get into my private EC2 one. I can go ahead and click Start Session. And now you can see, just like when I SSH'd into it, I am within my EC2 instance. And from here, I could go ahead and say sudo yum install NGINX. And because our NAT gateway is appropriately connected, it's going to reach out and allow me to download NGINX. And then I can say sudo systemctl start NGINX. And I can say curl localhost. And woohoo, we have our welcome to NGINX page. All right, so that's awesome. But the issue with this now is we have a lot of manual work that we're doing, right? Because that is just now we're working with multiple private instances. So I would have to go and do the same thing to my other instance. All right. So I'm going to terminate my session. All right. And I'd have to start and then select the second one and do the same thing in order to get it. Because if I look, I'm starting a session here. If I go ahead and say curl local host, nothing, right? Because there's nothing on here. I have to go ahead when I install something on one host, I'm not installing it on both, right? So I'm going to have to say sudo yum install NGINX to go ahead and do that. And then yes, and then sudo systemctl and so on. All right. So, but this is just showing you that I can get into this private EC2 instance using Session Manager instead of SSHing and instead of using a Bastion host. Bastion host will come into play in a future challenge, so you didn't learn it for nothing. And even if if it doesn't come into play, if it weren't to come into play, it's still good to know because traditionally that is what you would use is a Bastion host, but now we can use Session Manager. All right. In the next video, we'll go ahead and use Terraform to set up the IAM role and attach it to our instances instead of doing it manually. See you in the next one. All right, so we have our private instance, our private security group, and our VPC. All right, but as we saw in the last video, we aren't able to SSM into our private instance without creating an IAM role and attaching it to our instance. All right, can we do that manually? Sure. But why do something manually when you can do it with Terraform? All right. So I found this blog that kind of goes through it. It shows the code. The code works, but we're going to use GitHub Copilot after we write the code in order to learn more about it because the only sentence I really see about it is this. And to be honest, it doesn't fully make sense. And when we did it manually, it was still a little bit unclear. But that's something that's great about continuing to Google and research and use Copilot. You can get a lot more information just by having the code. All right, let's get started. So the first thing that we want to do is we want to create the IAM role. And what you can see here, and you know what I'm going to do while we do this is I'm going to Terraform apply. So that way I can get all of the resources that we had in the last video up and running again. All right, cool. So that's up and running. So if we go over here and let's go to IAM. All right. And then we're going to go to roles. And then we are going to create a role. All right. So we're creating an AWS service. And then we're going to pick the use case EC2. And then you're going to see that we are picking EC2 role for AWS Systems Manager. Next. And then you can see that we have this policy. So let's open that up and take a look. All right, so this allows us full access to SSM, EC2, and Systems Manager. And let's look at the JSON. So this is all of the things that it's allowing us to do when we add that policy to our role. So go to next, and then we name it, and then we have our trusted entities. Okay, so this trusted entity is kind of the part that I don't fully understand that we're going to look into a little bit. All right, but if you see here, we have the person who made this blog has the role for the developer resources. All right, so I'm assuming that what this is doing is saying who's allowed to use this role. We're defining a role on IAM and what is this role for? Okay, so let's get started. So just like we did in the console, we're saying we're setting up the role. What do we want to do? We want to create an AWS IAM role. And then we are going to name that role, and I'm going to name it EC2 role. All right, next we actually will give it a name. So I am going to name mine using our variable var.appname EC2 role. All right, next we have description. I'm probably going to leave that out, to be honest. And then we have assume role policy. So let's go ahead and look into how we do that. Uh, Copilot is helping me out here, so I'm going to go ahead and allow that. I'm going to pause real quick because my dog is barking, so I'm going to let him outside. 1 second. All right. So we have this assume role policy field, and then this is where we are going to put the role policy. They're using this here in order to do it. So I'm going to go ahead and look this up. So I have a super good understanding. So it initiates the here document, and the final EOF and indicates the end, the text sandwich inside. So we're creating like a doc by doing that. So let's do versus JSON encode. All right, so 2 ways to define policies. One is with EOF and one is with JSON encode. Ooh, okay, so this is saying that another way that we can do it is by using the data source AWS IAM policy document. That way, Terraform can validate your IAM policy, at least from a structural perspective. All right, let me look. Interesting. Okay, I think for now I'm not going to do this, but I will go ahead and bookmark this. And if anyone does do that, write up a little blurb about it and post it in the Slack channel, so that way we can kind of see how things go. So I think I'm going to use JSON encode here, and I'm going to then add my object. Okay. So if you see, we have this is our trust policy, and that is what I'm going to throw in here. All right, that looks pretty good. All right, so now we have our IAM role defined. All right, so you can see that that's step 1, select the trusted entities. So we have our trusted entities. Step 2 now is adding the permissions, which the permission that we want is this policy name here. Okay, so the way that we're going to do that then is we're going to do that with the AWS IAM role policy attachment resource. So I'm going to add that resource AWS IAM role policy, and we will call this EC2 policy attachment. I feel like my brain's not working today. We'll call this EC2 policy attachment. All right. Copilot is on top of things. So the first thing that we're do is role, and the role is going to be this role from up here. And perfect. And the next thing that we need is policy ARN, which let's go make sure. I'm just going to copy this to verify that's the right policy ARN. So we have step 1 and step 2 from when we were doing our manual all set up. Okay. Now, what is the third step? The third step is that we need to be able to then attach this to our instances. Okay. And the way that we attach it to our instances, so let's go back and let's take a look at our EC2 instance, which we have 2 of them, and they're both now up and running. And if you go to actions, then security, modify IAM role, you'll see that you attach it like this. Okay, so you attach it in the instance. Okay, but we need to have the profile that we can attach it to. Okay, so that's the third resource that we need to create. So we're to say resource, AWS, IAM, instance, profile, and then we're going to call this EC2 profile, and name, that works, role, AWS IAM role, right up here, .ec2 role. right there, dot name. All right. And that is just going to allow us to attach our instance, right, to this role. Okay. Which is attached to this policy. Cool. So now what I'm going to do is I'm going to highlight all of this because I feel like I'm able to do it, but I'm still feeling like I'm like kind of messing up my words as I'm talking about it. So that is when I'm not going to use Codium. That is when then I would use Copilot and I would go to explain this. All right. Then pull this open a little bit. The Terraform code is creating an AWS IAM role, attaching a policy to that role, and then creating an IAM instance profile that includes that role. All right, so we're on the right track so far. The first resource block, all right, so that's this one, creates an IAM role named Coding with Callie, EC2 role. The assume role policy argument is used to define the policy that grants an entity permission to assume the role. In this case, the policy allows EC2.AmazonAWS.com service to okay, so I'm glad we did this, to perform the STS assume role action, which means that EC2 instances can assume this role. Perfect. This makes more sense. I wasn't sure what this policy was saying, but basically we're saying that the EC2 service is allowed to assume this role to do the things that we want allowing it to do. What are we allowing it to do? We are allowing it to use this Amazon SSM Managed Instance Core policy. Let's read more about that. The second resource block attaches the Amazon SSM Managed Instance Core Managed policy to the IAM role created earlier. This policy grants permissions for EC2 instances to use AWS Systems Managers for features. Okay, so the role is saying, who is this role applying to? EC2 service. What is EC2 service allowed to do? Well, they're allowed to, let's find the good word for it. They are allowed to use AWS Systems Manager features. All right. The third resource block creates an IAM instance profile named Coding with Callie EC2 profile and associates the IAM role with it. An instance profile is a container for an AWS identity, so an IAM role, that you can use to pass the role to an EC2 instance at launch time. This means that applications running on the instance can use the role's permissions to access AWS services. All right, so that's exactly like what we thought too. This is then allowing us to attach an EC2 instance to it. All right, so we need to then use this profile and add it to our AWS instance. All right, and Copilot knows what we're doing. So we want to say that the IAM instance profile is going to be the AWS IAM instance profile, right? That's this resource here, .ec2 profile, .ec2 profile, .name. Now we're going to save it. Then let's go ahead and say Terraform apply. All right, let's take a look. So the VPC private route will be updated in place. Private route tables. All right, we will be, all right, I'm a little bit confused about those. So I was just reading through here. It's looking like it's just, I don't know, taking away the same thing that it's then just going to add. So I'm not concerned. All right, the private instance then is adding our IAM instance profile to both of our instances. And then we're adding our IAM role, instance profile, and policy attachment. Yes. All right. And then we should be able to take a look. All right, still modifying. Let's go ahead and take a look at IAM. Oh, Perfect. Let's go to our roles, and you can see that we have our EC2 role. Perfect. All right, let's go to now session manager. And let's make sure that our EC2 instances are attached. They are not, but I'm guessing it's because we didn't reboot our instances. So let's go ahead and select that and then do action. Nope, instant state reboot it. All right, we're rebooting. While we do that, let's go check to make sure that, yep, the IAM role is added. So hopefully this works now. All right, start session. Well, this isn't fun. Feels like we did it right. All right, permissions policy. All right, trust relationship. Is that what we put? All right, let's go look and compare. All right. Let's go back to Systems Manager. Sessions Manager. Start session. All right. So yeah, I would just had to wait for it to reboot. Sometimes I'm too impatient for these things. Okay. And then if we select an instance and start session, you can see that now we are in our session. All right. We will continue in the next video. All right. I want to start fresh with new resources. So I'm going ahead and destroying, but while we're destroying, we're going to move on. So now that we have the ability to SSM into our private instances, I'm really tired of installing NGINX, changing the NGINX homepage, and then starting NGINX. And when a developer feels tired of doing something manually, they automate it. So that's what we are going to do. All right. So what we need to do first is we need to create a bash script that then we can use inside of our private instance. Then we're going to use the user data field within Terraform to attach that bash script. And what the user data field is the user data field tells the private instance what to run when it starts up. Okay, so basically we can write a script that does the downloading of NGINX, changing the HTML file, and starting NGINX, and we can make it automatic. And why would we not do that? So let's get started. First thing that we want to do is we want to add a file. So I'm going to call it script.sh. All right. The next thing that we want to do is we want to tell the file that it is bin bash. All right. So that way it knows what the script is and what to run. All right. The next thing that we want to do is give it instructions. So just think back to when you SSH or SSM into an instance, what instructions do? You do sudo yum install NGINX. But here, we don't have to use sudo because when you're using the user data field, you're already logged in as the root user. All right. Now, if you remember, when you install NGINX on that instance, it asks you after it goes and connects to NGINX and gets the information that it needs to download. It shows you what it's going to download, and then it says, do you want to download this? Yes or no. So we need to add this -y, which is going to be the flag that says yes. All right. The next thing what we want to do is change that HTML page that starts. All right. So we're going to use the bash command echo. And yep, thank you, GitHub Copilot. That HTML page that gets shown is at the user/share/nginx/html/index.html. All right, that's where that file is located right here. All right, we can use the echo command and say, we want to put this string, hello world. We want to replace what's in this file with hello world. All right, and we'll just leave it at that. The next thing that we want to do is actually start NGINX. So you'll remember that we use systemctl start NGINX. And perfect, our script is written. The next thing we want to do, and the last thing before we can Terraform apply, is we want to add this to the user data field. All right. And you can see that it started doing the EOF thing that we Googled in the last video, and you could totally use that in inline, put the file, but we don't need to do that. Instead, we're going to say file, and then we're going to say // because it's in the same folder, and then we're going to say script.sh. All right, now we should be ready to say Terraform, apply. All righty, I'm going to say yes. And then I'm going to go ahead and pause here until it's up and running. All right, all of our resources have been added. Let's go take a look and see if it worked. All right, so I'm on Sessions Manager here, and I'm going to refresh. There are no active sessions. All right, let's start a session. Woohoo! And we have our 2 instances up and running. Let's go ahead and just pick one. We're going to start session. Also, I don't know if I said it in this video or a last one, but you can also use AWS CLI in order to use Systems Manager and Sessions Manager. Just a heads up. All right, so if I curl localhost, I should see hello world, and I do. So this worked. All right. So now you can use the user data property section in order to run bash right on your right on your instance as it loads. All right. Now what's next? Next thing that we need to do is we need to be able to access our application, our hello world, from the outside, okay? That's making me think of Adele, so I already know how we're going to edit the HTML file. All right, instances. If you look at our instances here, you can see that we do not have any public IP address, and you'll remember that they're in the private subnet. So we don't have any way to actually see what's going on our application without getting into the instance. We're going to change that in the next video. See you soon. All right. So before in our previous challenges, we used public EC2 instances as a load balancer in order to redirect the traffic from the public subnet into our private subnet in order to see our application. The reason why we did this was A, to learn, and B, because we only had one availability zone. But now in our new architecture, we have 2 availability zones, which opens up a new resource for us, load balancers. All right. So we are going to manually create a load balancer for our application. So that way we're able to see our application from our private instance. So we're going to go ahead and click create load balancer, and you'll see a few different types of load balancer. So we are going to create the application load balancer. All right. Create, and we're going to name it. So we'll name it Coding with Callie Load Balancer. We want it to be internet facing because we want to be able to access this from the internet. And you'll see that it requires a public subnet, which we have 2 of in 2 availability zones. All right. We need to select our VPC. So we're going to use the Coding with Callie VPC. And you can see that we need to select at least 2 availability zones, 1 subnet per zone. So this is why we weren't able to use a load balancer before. Now, the more instances you have deployed, the more availability zones that you're deployed into, the more money you're going to spend. So that's why we started with a very simple architecture, because it's easier to learn with a simple architecture, but it's also more cost effective. Now, if you're at work and you're not footing the bill, you're going to want to use the production ready multiple availability zone, because that's going to make sure that your users aren't having an issue. If you don't have any users and you're just deploying a portfolio project, you probably don't need multiple availability zones to do it. All right, so there are different choices to be made and different pros and cons of both, okay? That's why I'm showing you the different types of setup that you can use. All right, we're going to select both availability zones, and yet we want to do the public subnet in both. All right, and you can see it's going to yell at us if we're in a private subnet, so we'll switch that to the public subnet because it needs to be public. All right, security group. Create new security group. All right. Inbound. All right, so for our security group, we pretty much want to just allow traffic anywhere on port 80. The reason why we're using port 80 is because that is where HTTP traffic comes from, and we don't have anything else other than HTTP traffic right now. And outbound traffic is everywhere. All right, cool. I guess let's add a tag, and we can see coding with Kali, load balancer, security group. Coding with Kali, load balancer, security group. Coding with Kali, load balancer, security group. And we want that into the coding with Kali VPC. Create. All right, so we have our security group. Let's go back. And we can select nope. Let's refresh. And we can select the load balancer security group. All right, so now we have listeners and routing. All right, so we're only using HTTP right now. So we're listening on port 80 because that's what HTTP traffic is sent over. And then we need to select a target group. All right, we don't have a target group yet, so we're going to go ahead and create one. All right, instances is going to be our target type. Protocol, yep, HTTP port 80. VPC, that's fine. Health check is fine. So then we're going to click next. Target group name, coding with Kali, target group. Also, we're doing this manually right now, but we're going to Terraform it after. So if everything's not named perfectly, it's fine. All right, so now we can register targets. We're going to select both instances. Both ports will be 80. Okay, include as pending below. I always miss that button. I don't think the UI is great on that. Okay, our targets. Now we create a target group. Perfect. And we can go back. Let's refresh so our target group pops up. It's there, which will be both of our private instance. Dun, 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 dun. And now we have our summary. So let's go ahead and create our load balancer. All right. It might take a few minutes for it to set up and route traffic. All right. And targets will also take a few minutes to complete the registration process and pass initial health checks. All right, so I'm going to go ahead and pause the video here then. You can see that the state is provisioning. Once it turns to active and is green, I will resume recording. All right, it is the moment of truth. We now have an active load balancer. So this is how we use it. We go ahead and take the DNS name. We copy that. If you open it up, it's just a big URL. And then we can open new browser and click enter. I'm going to close some of these that I don't need. The first time it does take a while to load, and it loaded, and we see our hello world. All right, so we now officially have completed most of our architecture. Well, all of our architecture, except we created the application load balancer manually, which in the next video, we will use Terraform instead. Something else that we need to do is, it says hello world, but you'll notice that what we did is when we attached the targets, we attached, so let's go in here. So we have a target group, but you'll notice that we have two targets, all right? We have the private EC2 instance 1 and the private EC2 instance 2. And what I want to see here is I want to be able to see which instance I'm looking at when I refresh the page. So this hello world is just not going to cut it. But we will keep on keeping on and make our application even better in the next video. All right.
we know how to create the application load balancer manually. So that means it's time to learn how to create it with Terraform. All right. So as these things get more complicated, you're going to need a bunch of different resources. If you remember when we set it up manually in the last video, there were a lot of pieces to the application load balancer puzzle. So what I like to do in order to fully understand it is use some resources. The first is this really cool blog that we have here. They have a more difficult architecture, but I like that they kind of walk through step by step what resources need to be created. We can also use Terraform registry to get some examples. And the final thing that we can use is we can actually use AWS and manually kind of go through the process so that way we can actually look at what is happening. So in order to create a load balancer, we create the load balancer and then we create it, okay? So we have to name it, say whether it's internet facing or not, the IP address type, the VPC that it's in, and then we would map it to the availability zones, okay? So we have 2 availability zones in our public subnet. Bum, ba-dum, bum, bum. All right. So let's go look at the actual application load balancer here. All right, you can see that it has a name, internal or internet facing, right? So internal false, the load balancer type, right? So when we were on this page here, we were selecting the type. So application, network, or gateway. So application, the security group that it goes to. So we'll also need to create a security group for it and the subnets that it will go into, okay? That should be good. The access logs, I'm guessing will have to do with where we're sending our logs for the load balancer, and then we have tags. Okay, so I'm gonna say we don't need some of these things, but some of them we do. All right, so let's give it a try. So we're gonna say resource, AWS load balancer, and then we will name it load balancer. All right, so we will need a name. That sounds good to me. We will need internal false. That sounds good. Load balancer type, application, security group. And then here it's adding in a security group, but we don't have a security group yet for our application load balancer. So I'm going to leave that blank for now. And then we have our subnet, and yet we want it to be in our public subnets. So that's great. Let's look into the security group a little bit. Well, let's see. All right, so internet facing, let's put it in the right VPC. So we map it to our public subnets. So that's the first availability zone that we have in this VPC, and we're going to put it in the public subnet. Here's the second one, and we're going to put it in the public subnet. All right, so that's what we're doing in this line here. All right, security group, we are going to create a new security group, and it's going to open up a new thing that tells us this is a new resource pretty much. So let's make it then. So we're going to say resource, and let's go to AWS security group Terraform. All right. So you'll see this note, and actually Dan from our cohort brought this up, that we're writing inline ingress and egress rules, and that's kind of an outdated way to do things and could cause problems in other areas of our code. So we're going to refactor a little bit of our other security group later, but in this new security group we're going to make it the correct way. All right, so we're going to say resource, AWS, security group, and then we will name this security group load balancers security group. And then we will name it. Perfect. Description is fine. VPC is fine. And then let's add a tag. Perfect. I love Copilot. All right, so that is going to be our security group in general, but you'll notice we don't have any rules for that yet. So we actually have to do an ingress and egress rule here in order to make everything work out. So for our ingress rule, let's start with that first. All right, we can kind of
copy. Trying to figure out if I want to copy or just retype. I'll try to retype. So we're going to say resource, AWS, VPC, security, group, ingress rule. And then we're going to say allow TCP traffic. All right. And we will have the security group ID, which is correct. We're going to say from everywhere, we want to allow TCP traffic to and from port 80. That allows us to do HTTP. And apparently we are missing the IP protocol. And we just wrote protocol. Well, GitHub Copilot just wrote protocol. All right. All right, that should be good. And then we also need an egress rule. So we can say resource, AWS, VPC, security group, egress rule. And then allow all traffic is fine. All right, security group ID. Yep, we want to use our load balancer security group. And we will be basically allowing traffic everywhere, all outbound traffic. Okay, so this is I'm trying to debate whether I want to add ingress or inbound or outbound, but I guess technically the resource tells us that. All right, so then now in our security group, we can add our AWS security group.lbsg.id, and that will be the ID of our security group to attach to our load balancer. So that way our load balancer allows HTTP traffic in and all traffic out. Perfect. All right, so now let's go on to our next thing. So that would be when we are using, right here, we're setting our inbound and outbound rules, our VPC that we're in, right, for the security group. All right, so go back. I'm just going to set the default because we're not actually making this. So the next thing that we're looking at is listeners and routing. So we have a listener here that's going to be listening for protocol HTTP on port 80 and then has a default action. Okay, so we need it, and then we have a target group. So that's going to be the other resources that we need to set up. We need to have a listener, all right? We need to have a target group, and then we need to attach our instances to the target group. Okay. So if we go to our blog, we can see how we do a target group here, okay? This is how you do the target group attachment. And this is how you create a listener. And that's going to be our last 3 pieces of the puzzle. All right, so let's go ahead and create that. All right. Sure, we will start with the target group. All right. Let's see if we got this right. Name, that would be Coding with Callie. Target group, that's fine. I'm trying to think if I want load balancer in that, but no, it's okay. Port 80, protocol HTTP, and VPC. Perfect. All right. So now this is just saying like our target group's going to be in this VPC looking for HTTP traffic, and this is the name of it. But we actually need to attach the actual instances to the target group. Okay. So then we will do resource, AWS, LB, target group attachment. And here, perfect. It already knows what we're doing. We want to have 2 attachments because we have 2 instances in our private subnet. The target group ARN is, going to be from our target group. This is how we're associating the target group part of things. Perfect. And then our target ID is going to be our private instances, and we're going to use count index to identify each one and on port 80. Perfect. All right, the next thing that we need is, yes, Copilot, you are doing so great. We need our listener. So let's go scroll down a little bit and create our listener. Oh, so that's them creating their application load balancer, but we already did that here. All right. So now we need to do our listener load balancer ARN. So that is going to be, yep, our application load balancer.load-balancer.arn, right? Application load balancer.load-balancer, and then the ARN is going to come from that. Port 80, protocol HTTP. So it's going to be listening on port 80 for HTTP traffic. And then, yep, our default action when we get that coming in. So it's basically our load balancer is listening for things that are communicated. I'm going to say people. It's listening for people who want to communicate with it, right? So it's like your ear, all right? I'm sitting here, my ear is listening just in case my husband wants to talk to me or anyone else wants to talk to me, okay? The way that they can talk to me is through English, all right? Because that is the language that I speak, all right? So the protocol or the language, not really the language, but our listener for our application load balancer is going to be listening for HTTP traffic on port 80 because that's what HTTP traffic goes on. All right. And then and then the default action is explaining, well, what do we do when we get someone talking to us? Okay. Well, we're going to forward that traffic. Okay. And we're going to forward it to our target group. Perfect. So this should hopefully work. All right, we already have all of our other resources, so we should be able to just say Terraform apply, and let's see. And yeah, let's see what happens. I don't know how long this takes. Oh, you know what we also have to do while this is running? Let's go look at our private instance. All right, because the security group for this one, we're saying that we want to allow all traffic in, but we don't need to allow all traffic in to our private instance because we only need to allow traffic in from specifically our load balancer. So we should be able to, instead of saying CIDR blocks everywhere, we should be able to do security groups and then AWS security group, load balancer security group.id. And that should work. I'm gonna have to Terraform apply again after that, but I'm gonna wait for this. So I'm gonna go ahead and pause this video and I will resume when this is done loading. All right, we just went ahead and finished applying our changes. I haven't applied the security group change yet, but let's go first and cancel the creation of our load balancer. We have our load balancer here. I'm gonna make this bigger. You can see the state is active. Click on it and fingers crossed that we did everything right. The first time it loads, it takes a few seconds, so it's not necessarily wrong if it takes a few seconds to load, but woohoo, we see our hello world. All right, so now what we can do is we can Terraform apply again, which is going to take into account this security group change, and we want to test that before we kind of go anywhere. So for to change, wow. All right. Looks like it changes these route tables a lot. All right, so we are going to go ahead and apply that change. You may not specify all protocols on. All right, let me take a look at this. 128. Invalid parameter value. You may not specify all protocols and specific ports. Please specify each protocol and port range combination individually or all protocols and no port range. Interesting. All right, well, let's try to GitHub Copilot because why not? And we'll see how it goes. All right, so when I GitHub Copilot, I click copy it and then I just say explain this error to give me a little bit more context. I'm a little confused because it's talking about line 128 and we previously applied this already. All right, this error message is indicating that you are trying to specify both all protocols and a specific port range in a security group, which is not allowed in AWS. In AWS, when you are creating a security group, you can either specify a specific protocol like TCP, UDP, ICP, and a specific port range. From port to port. It's just weird because like this is definitely what I had in the previous egress rule. All right, so I think I'm going to finish the video here, which is kind of a sad finishing of the video, but we'll pick up in the next one. I'm going to do a little bit of research to make sure I understand where this error is coming from and what it's doing, and we'll address it in the next one. See you soon. All right, so the answer was staring me in the face, and I needed to see an example to make it make sense. But okay, so when I was doing it the old way with egress, it worked to do from port to port protocol and the site of rocks, right? When you're doing it the correct new way, where you have the egress rule, what it's saying here is if you want to allow all traffic on all ports, you should specify all protocol calls, which is this, okay? For that, wait, all protocols and no port range. If you want to allow all traffic on a specific port, you should specify the protocol for that port and the port range, okay? So this is allowing all protocols, all right? So what I'm going to do is I'm going to just verify that by explaining this. Mm-mm. All right, so this line is specifying the ID of the security group to which this egress rule will be added. It's referencing the ID of the security group defined elsewhere in your code, right here above. All right, the CIDR IP4 and then the 0.0.0.0/0 line is specifying the range of IP4 addresses for which this rule applies. The CIDR block 0.0.0.0/0 represents all possible IP4 addresses. So this rule applies to all outbound traffic. The IP protocol -1 line is specifying the IP protocol for which this rule applies. The value -1 represents all IP protocols. So this rule applies to all outbound traffic regardless of protocol. In summary, this code is creating an egress rule that allows all outbound traffic from the resource associated with the specified security group to any destination. All right. So that makes sense and is what we thought. How did I come to this? Is I looked at the Terraform example for allow all traffic IP4, and I see that it says it's semantically equivalent to all ports to write this. Okay. So that is how I came up with it, is just following the docs, which is typically the right way to go. All right. You'll see that I applied 3 changes. What I did was I added, where am I? You can go to the security group. I added for the ingress to my private instances security group, I added that the security group would be the load balancer. So only traffic coming from our load balancer is allowed to talk to our private security group instances. All right. Now that we're here, though, we are going to go ahead and refactor this a little bit. Okay, so first I'm going to head back to AWS. I'm going to refresh. I have my load balancer. I'm going to go ahead and put it in here, and we still see our hello world. So that means it is working. Yay, us. All right, the next thing that I'm going to do is I'm going to refactor my security group a little bit. So that way it makes sense in the new way that we do things. So I'm going to copy the security group that I had for the load balancer. I'm going to move it up to the security group that we have here. All right, and then I'm going to edit it. So instead of AWS security group load balancer security group. I'm going to call it private security group, which is probably to cause issues because I have it as coding with Kali private here. That's okay. I'm going to have it be var app name, so it's coding with Kali, and then instead of LB, I'm going to have it be private. For description, I'm going to have it be private security group. VPC is fine, and tags, we will tag it with coding with Kali from the variable private SG. All right, so then we are going to attach an ingress rule to that security group. We're going to attach it to the private security group, and we're allowing TCP traffic from load balancer. All right. So we're going to get rid of this CIDR IP4, and instead we are going to add source security group ID. All right, I don't think that's right. It's not expected here. So let me just try the security. Why is it security group ID? Does that work? Well, it doesn't really like that either. Go to explaining using Copilot. Oh, because this is what we're saying it's from. So how do we do it here? It's just security groups. So let's see if it's named the same thing. Unexpected attribute. Let's see if Copilot knows what the expected attribute is. If not, we'll do what we're supposed to do, and that's look at the docs. All right, come on, Copilot, you can do it. Oh, wait, so it does use source security group ID. All right, let's try that. It was mad at that before, though, so source security group ID is equal to AWS security group dot load balancer security group dot ID. Also not expected. Let's try one more time. And we will go back. All right, the source security group ID attribute specifies the source security group for the rule. No, I specifically want to explain this error. All right, so let's do AWS security, AWS VPC security group ingress rule Terraform. All right, see. All right, this will create an ingress rule for the private security group. It doesn't have a source security group ID attribute. Instead, it uses CIDR blocks or source security group ID. That makes no sense. All right, to Terraform we go. Referenced. the source security group that is referenced in the rule. All right, let's give that a try. So a lot of this trial and error, trying to figure out the best way to do it. Reference security group ID. All right, so it seems a little bit happier with that. All right, so before I apply that, I'm actually going to have Copilot now explain this and see if it explains this section. It's defining an ingress rule for security group in the AWS VPC. The allow traffic is defining a new ingress rule. So it's adding the ingress rule to this group. The protocol. In summary, this code is creating an ingress rule that allows TCP traffic on port 80 from the resources associated with the load balancer security group. All right, I think that is correct. Okay, so we have our ingress. Okay, our egress should be the same. All right, but instead of here, we are going to have it be that. All right. And then we should be able to, I'm going to shrink this down, and I'm actually going to just comment it out for now. And I'm going to say Terraform apply and see what errors we get. We already have it named. So allow all traffic to private. Okay, and then let's change this one to allow all traffic to LB. I was wondering if it was going to be mad at my name. Oh, okay, and we changed the name of our private security group, so line 94. So it's no longer called Coding with Callie Private SG. It's just called Private SG. The reason why I changed that is because none of the other resource names have Coding with Callie in them, so it makes more sense to have it that way for consistency and readability. All right. So I'm going to go ahead and pause and wait until it comes up, and I will see you in a minute. Just wanted to update you. We are still destroying, so I'm a little bit nervous, but hopefully we get there, and if not, we'll debug the error together. Pausing again. So I think renaming my security group confused everything, so I'm just going to go ahead and delete everything. I'm destroying everything, and then I'll spin everything back up. I'm going to have to manually delete the Coding with Callie private one because I have it commented out, so it doesn't really know what to destroy. I don't think, so I'll be back. All right, the moment of truth. All of our resources have been added. Let's go see if changing our security group and refactoring worked. All right. So far, I'm okay with it taking a little bit to load. I'm hoping we see that hello world. And yay, we do. All right. So this is awesome, but I don't like that it just says hello world. I want to know what private instance I'm looking at. So that's what we're going to do in the next video. See you soon. All right, so we need to edit first this file. Here, let me close out of all of these. We need to edit this file here, okay? I don't want it to just say hello world. I want it to say hello world from, and then the instance or whatever that we're looking at. Okay, I'm fine with just saying hello world from 1 or 2 using like the instance count. So that's what we're going to try to do. So in order to do that, we need to pass a variable to this file. Okay, so instead of using the file function here, we're going to use this template file function. All right, it allows us to say a path and then some variables that we want to supply that file. All right, so we're going to say template file like that. All right, so this is our path, and then we're going to say comma, and then we're going to do our variables that we want to use. So I am going to type in that our instance, should we do instance ID? Sure, let's do that. All right, so then this will send in our instance ID for whichever instance we are looking at, right? We have a load balancer in front of our instance, and then it's either it's forwarding traffic to one of our instances, okay? So anytime a user accesses our application, they're actually going to see the application that's on instance 1 or instance 2, right? But they actually have an ID, so we will do that, okay? So then we can go over to our script and then we can say, let's write some HTML in here. All right. Let's do a body. All right, and then let's do a heading 1. All right, so instead of hello world, I'm going to say hello from the other side. All right, and then maybe I'll do an H3. Let's do my H3 content. Then I say, yay, you are viewing this application on the instance on private instance. And then we are going to use our variable private. I think it's instance ID. Instance ID. Okay. So a little Adele for us this time. And there we go. So let's hope this works. Fingers crossed. And I'm going to Terraform apply. The reason why I destroyed and then applied, well, A is cycle AWS. Is it not like this? I don't know what this means. I'm gonna look this up on Copilot. Explain this error. This creates a circular dependency because the instance needs to be created to get its ID, but it also needs its ID to be created. All right. Oh, we could do the name self.id. Oh, wait. You could use a tag and then retrieve it from the script. All right, I think we're just trying to get a little too fancy with this. It's kind of defeating the point of the exercise. So we are just going to instead, so basically what it was saying is that I'm trying to reference the instance ID, but the instance ID isn't a thing until after the resource is created, but this user data is used when the resource is created. So you're going to have issues in terms of chicken or the egg, essentially. Okay. So now this will work. All right, I'm going to let it apply and I will pause and then we will resume to check to see if what we did worked. All right, our resources are ready. We have an active load balancer, so let's give it a try. Fingers crossed. I'm gonna be sad if it doesn't work because I have to make dinner now. Woohoo! Hello from the other side. You are viewing this application on private instance 2. All right. And now I refresh and I'm on private instance 1, 2, 1, 2. Woo, woo, woo. All right, very cool. We did it. That was the end of challenge 3. I hope it was fun. I hope you learned a lot. I certainly learned a lot, and I really appreciate everyone going through this with me as we learn how to deploy and all the ins and outs of manual deployment and automated deployment. All right, see you next week.